È una
Hello everyone. Thank you for coming. Yeah, let's change to speed. Okay. As you can see, I'm slightly smaller than Jesus, so that means I will not be your host. Jesus will be the one doing all the talk. From my side, I would just like to introduce a bit what are we doing at AXA. So AXA, as you might know, is a big insurance company, but as well we give support to open source, and we have a lot of we're trying to do a lot of things on the open source communities and trying to get more engagement on the development communities. And as well, one of the things we did, basically Jesus as well, on one of my teams, is to work together on an NLP solution for JavaScript, for Node.js. Okay, so he will cover that in a bit more detail now. From my side, I mean, you might know, okay, AXA is insurance company, okay, it's boring, but we do a lot more things that you cannot maybe guess. Okay, so of course, we do have the boring insurance application. Yeah, we do that, but we do a lot more things. So if you are curious, you would like to know more information. I mean, we are hiring as well. So if you would like more information, just contact me. You have my Twitter. Well, you can contact me on Twitter or just grab me here after the meetup, and I'm happy to explain. And as well, please feel free to use this NLP. Feel free to contribute as well. Basically, it's open source, it's for the community. So, Jesus will explain the interesting things.
I am this guy, 10 years after. He is the head of engineering. This is a good job. I am software architect according to the contract, but my real job is hands of innovation, because if he is the head, well, excellent. I do the stuff.
Looking for other parts as well.
So he thinks he do a super job with PowerPoint, and I implement it. So what we are talking about today, we are talking about NLP. Here are the URLs. If you want to take a picture or enter or join or whatever, where is the source code? Okay. If you click in the first link is the library. The library is a library. So it's JavaScript, and it's also compiled, so can be executed completely in the front end, in the browser. So you can have an application working in the browser without calling the backend and having an artificial intelligence with a chatbot right in the browser. The models that this train are JSON files. So the JSON files can be interpreted also by Android and by iOS. And the computing that it requires to train is very hard, but to execute the model is only to sum and multiply by numbers. So it's not a big stuff for a mobile of today. The second one is a Node.js application, a backend done in Node.js and Happy, and a frontend done in React. So in the first one, you need a developer to use it. Sorry. In the second one, you can deploy it. It comes with a button that automatically deploys in Heroku an instance with the database in MLab MongoDB for free. And this is for someone that is not a developer, can use the chatbot, can deploy, can do whatever he wants. Okay? It's multi-agent. What means that it's multi-agent? That you can handle several chatbots in the same application. So, NLU. So, today we are talking about how to implement an artificial intelligence to handle conversations. Okay, and we want to handle conversations as well as the big companies. We want to handle conversations as well as Microsoft does, as well as IBM, as well as Google. Okay, so if we want to achieve this target, if we are going to the top, we need to handle several parts of an NLP. And the first one, the more important, is the NLU, Natural Language Understanding. Okay? So, there are several ways to do it, and some of the ways are very hyped today. When we are talking about NLP today, most of the work is done in Python using NLTK, that is a library for TensorFlow to handle NLP. And when you are talking about NLP, most of the current conversations and most of the current conference talk about three things. The first one is the Lsdm. The Lsdm is long short-term memory, and it's a recurrent neural network. What this means? Okay, we have handled the problem of having the NLP, of understanding the human, character by character, with a neural network that has a little memory, so it's able to memorize some patterns of the characters. What's the problem? That is not the best approach for chatbots. It's a great approach when you have a big corpus. A corpus is what you have to train. Okay? If you have, for example, the Lord of the Rings, and you apply Lsdm. Hello? Hello? Welcome.
Sorry.
If you go with Lsdm, you will find two things. First thing, it takes the life to train. Okay? The Lsdm recurrent neural network is a very complex problem, and being a very complex problem means that you need a lot of GPU to train a model. And the second thing that you will discover is that for a small corpus is crap. Okay? So, I will show directly in code. So I have a little exercise. Bigger. Is big enough? I can read from here. It's big enough. Okay. So we have a file that is a corpus that has several utterance. Remember the word utterance, it means sentence, but it seems to be more cool. We have several utterance and a category. We are talking about something on computers and can be classified as software or hardware. Okay? So this is the corpus, and this is the code. It's simply to require the brain.js library, that is a cool library. It's not as complex as TensorFlow, but it's good enough for some problems. And we create a new network that is a Lsdm. Okay? And what we do is to break the corpus and create from the corpus the format that the Lsdm network needs. Okay? And then we say, okay, train the network with the training data and use 2000 iterations over the data. Okay? So, after that, we want to classify. I fixed the power supply. I fixed the power supply is hardware or is software?
Hardware.
Hardware, okay. And the code has some bugs. Is hardware or is software? Okay. And if I find... Okay. Oh, sorry. Here, better. If I can execute, as I said, the Lsdm, one of the limitations is that takes the whole life to train. As we see, the corpus is very small, and I am walking to here, and still straight. Okay? And it will take more or less a minute, or a minute and 10 seconds. Why it takes so long? Because it's going character by character, and it's going character by character by an array of neurons with memory, and it's iterating 2,000 times. Okay, it's longer. You can have time to think, time for a coffee when it's training. For real compus, you can imagine that it takes days.
And the fun of the notebook is overwhelming.
Yes, yes, because it's training with CPU. Usually, when you train a model with Lsdm, you train in a GPU. You train in NVIDIA or online in an NVIDIA array. Okay, train it, and I fixed it. The power supply is identified as hardware, and the code has some bugs. Is identified as software. What's the problem? The corpus was big enough. But let's try with another corpus and more intents. Okay, so if we find the mouse, this corpus. Okay, we are targeting 3 intents. Who are you? Who are you is the test. Say about you. Why are you here? Then developer. Who developed you? Who is your developer? Who do you work for? And birthday is when is your birthday? When were you born? And date of your birthday. So we have an index 32 that does the trains with this corpus, and we are trying to classify. Tell me about you. Who is developing you? Who? And tell me when you born. Birthday. So if I go to the code again, it will take again too much time. Too much time?
Why? File is big.
No, the file is very short. It's only 9 lines. But Lsdm goes character by character. Okay? And it fails. Tell me about you, who is developing you, who. Tell me when you born it, developer. Why it fails? Because the corpus is too small to handle that with an Lsdm. The Lsdm is very fine when you have a big corpus. For example, the full documentation of a product, it will be able to learn from all this stuff and be able to answer some open questions from the, but will take a lot of time. Okay, so is good this approach for chatbots? No, because usually the persons only have they have not enough utterance per intent, and usually you don't have a big corpus of utterance and intent. Okay, usually you tackle a smaller problem. That is, I need to know, for example, if my user wants to contract an airplane or something like that, and this is not the right way to do it. Okay, so the first hype thing that you can hear about in NLP, that this Lsdm is not the appropriate for the problem of chatbots. The second one is the POS. POS is position of sentence. And if you remember when we were in the school and we say this is the name, this is the verb, and this is the adverb. It's exactly what they do. Okay? So our neural networks or heuristic algorithms to know every single part of the phrase. And it's the way that some chatbot platforms works. Okay? I will not do an example, but we will tackle more on the neural network part. And the position of sentence usually is not done so much with neural networks. And then is word-to-vec. Word-to-vec changes the word 2 years ago when Google presented the paper. Word2Vec proposed that. Okay, let's study a text, and for each single word, extract a vector in a multidimensional space where each dimension means one characteristic of the text. There is represented in a plane because unfortunately we don't have several dimensions to present a multidimensional space. But you can see the concept: man, king, woman, queen, and so on. So each word is a vector. And this allows to make some cool stuff. You can do algebra. You can do algebra with the words, because each word is a vector, and you can subtract vectors, and you can sum vectors, and you can multiply vectors, and so on. So what happens if I do king minus man plus woman? That I am in queen. So if you do this operation, king minus man plus woman, you will have queen. If you study the capitals and countries, you can study the relationship between the cities and the countries. So if I do France minus Paris plus London, you will have England. And if you do Paris minus France plus England, you will have London. Okay? This is a very good way to study a text, but not really what we want when we have chatbots. What I want when I do a chatbot is, okay, I have a sentence from my user. I want to know what the user wants. I don't want to go through every word of the user and study the vector of the word. It's a way to tackle the problem. And in fact, Rasa from Go Last Mile use Word2Vec because they use Spicy and Mighty, okay? That are thinked for big corpus. And we will see what happens when you tackle the problem with Word2Vec and with neural networks. So, once I discard this for the presentation, because it's not the objective to study Word2Vec, I started to work with chatbots using tools from third parties, and then I started to do my own NLP. And I started to think about this law. This law is, when it's marketing, is artificial intelligence. When it's a job offer, it's machine learning. And when it's implementation, it's a linear regression. It's a joke, but it's very true. When you are working with machine learning, with artificial intelligence, with neural networks, most of the problems inside, at the end, are linear regressions. What means a linear regression is to calculate the formula of a line, and you must calculate this formula. So we will learn how a linear regression works. We are not only here to code, also to understand. So the first thing is, what is a regression and what is a classification? A regression is that the problem that you want to tackle is to calculate the curve that best fits your points. And a classification is, okay, I have something here and I have something here. I want something to classify, okay? And how the neural networks do this? Because you have training data, some of the points are training data, and you train with these points, and then you, for example, this point is not from the training data, and you pass this point, and you expect that is classified as red, and this as blue. Imagine that it's not red and blue. Imagine that is the salary based on the age. Okay? If it's enough for a risk, if you want to contract a house or something like that. So, how neural networks are able to, based on the points, calculate the line. Okay, a line, the formula of a line is A multiplied by X, you have the X, but not the A, plus B. What is the b? The b is the displacement of the line or curve over this axis. Okay? So you must calculate this a and this b. And how do you do that? Okay? To do that, you need something that is called the cost, loss, or error function. What is the cost, loss, or error function? It's a function that the smaller the function is, the best fits your curve to that. For example, in a line is the less squares. You have a function that is these points, you calculate another line here, and you calculate the less squares from the points to the line. Very big. If I go here, it's not so big. If I fit the curve, it's very small. Okay? And you, a neural network, only have this cost function, and the only thing that the neural network knows is the amount of variables and the training data. And it does using something called perceptron. So, to understand it better, even better, okay, let's imagine that you have the points. It's very easy to, okay, if I move the A, I am there, okay, I can move, and here is the error, my loss function, and it's very small, and I can even fit more, I can do that, and if I go down, okay, it's even smaller. The problem is that a neural network is blind, doesn't see the points, only see the error. Here we have the error, 63. If I move, okay, I am discovering that it's smaller here, it's smaller, there is a point, and I can get it even smaller. So if I show the points, I almost fit it. And a neural network does exactly what I did here. It's blind, it's totally blind. Only knows the error function. And moving the A and moving the B is calculating when the curve fits better. Okay? And to do that, does exactly what I did. Is moving small pieces of A and calculating if it's getting better or getting worse, and it's moving B and calculating if it's getting better or getting worse. It's the only thing that a neural network does. So it's very easy, no? To do that, as I said, I moved A and I moved B. And I have a step. This is not continuous, this is discrete, so I need a side of the step. The side of the step in artificial intelligence is called learning rate. Okay? And the smaller the learning rate is, the best fit you will get. And the bigger, the faster will be. So you need to get a number that takes not so time to train, but is good enough, the training. Okay? And to do that, remember that we have the error here. Okay? What is doing the artificial intelligence inside is drawing something called gradient. Okay, he starts with one position and says, okay, the error is this number. Then moves A and calculates the new position. And he is drawing a curve that is called gradient, and he is moving through the curve using the derivative, the tangent of the curve. So he's calculating how to get to the lower point of the function, to get into zero in the error. Okay? So this is what happened. In the first case, you see that the learning rate is very small, so it takes more steps to get down the curve. The middle is good, and the right one is so high that we'll never reach the value of the cube. Okay? But this is for one line. The artificial intelligence never is only one line. There are several lines, and there is a theorem that is fundamental for this, that is the Taylor's theorem, that says that every continuous function derivable n times in a point can be represented as a polynomial function. And if we combine several lines, we have a polynomial function. And given the fact of the Taylor's theorem, if you are targeting a continuous function, I am getting too mathematical, I think. Okay, but basically with the polynomials you can represent any curve if you have a complex enough polynomial. And this is one example. With one line, with only one line, you can represent the and you can represent the OR, but you cannot represent the XOR. Okay? For the XOR, you need two lines. Otherwise, it's impossible. If I want to, this is the XOR representation. If I want a 1 is here, I need two lines to detect where is 1, where is 0, and where is 1. Okay? And this is one of the cases that I can, with more than one line, classify several parts of the space represented by my function. And the other case is that. Okay? If I want to represent more complex cubes of one grade, in this case, I only need, for a line I have A and B, the bias. For a curve, I have A1, A2, and B. And what happens? That this is a perceptron. A perceptron accepts several inputs, and for each input, he is varying the weight of its input and the bias. Okay? I will return to the representation of the perceptron because now you can understand the perceptron. Okay? It's only a thing, a function that sums x1 multiplied by weight 1, x2 multiplied by weight 2, blah blah blah, and also sums the b that is called bias. And after that, if we are talking about a classification, it uses something that is called activation function. What is the activation function? Remember the regression versus classification? In regression, you want a number, a real number. In classification, you usually want yes, no, green, cat, whatever. So that means that you are getting binary there, and you want a function that the higher your value is, more near the 1, and the lower the value is, more near the 0 or minus 1. Okay? So, a neural network is a combination of this perceptron. And usually it's done by layers. I don't have a slide for that, I missed that. But imagine that you have your input, 3 variables, for example. You can have several neurons here, totally connected to your variables. Each line from an input to a neuron means a weight that must be calculated. So if you have 3 variables and you have 3 neurons, there is 9 lines per input. No, sorry, 3 lines per input, totally 9 lines, okay? And you can have more layers here and also connected one to another. So you have a lot of variables, and what an artificial intelligence do is to modify little pieces of these variables, calculating what fits better. But if you have only one layer, you are getting several lines. If you add a second layer, you are getting polynomial, a 3 of grade 2, a 3-layer polynomial of grade 3, and so on. Okay? So you can calculate any continuous function using artificial intelligence. Artificial intelligence is a good way to recognize pattern. It's not Terminator getting here to manipulate all of us. So now this is the basis to understand, and we can start with what is NLU. NLU is Natural Language Understanding. So 1 year ago, there was a paper, a basic academic paper that is called SIGDIAL 22. SIGDIAL 22 is a corpora. Corpora is the plural of corpus, consisting of three corpus extracted from real life cases. It has cases from a chatbot that is the transportation chatbot from Munich. Okay, it has a corpus that is docs extracted from Ask Ubuntu, and it has one corpus that is phrases extracted from one forum or board that is called Web Applications, that is for us alternatives to Facebook, or how I update my Telegram, something like that. So based on these three corpus, it tries several NLPs commercial that are in the market, okay? And see how good those NLPs are. And to do that, every corpus has some sentence and the answer marked as training data. And other ones that is, once you have trained it, you have to guess the intent from the other phrases, from the other sentences, okay? And we see that the champion on that is Watson, okay? 92% of good guess, that is correct. Then you have Microsoft Lewis. Then you have Botfuel. Watson is from IBM. Lewis from Microsoft. Botfuel is from Botfuel. Recast.ai, that is a French company that was bought by SAP. Rasa, this is from a company called Go Last Mile. And Dialogflow, that was API.ai, that's what Google came and bought them. See, that are not the best guessing. The artificial intelligence is very crappy. But the features that the web has are better than Watson, Lewis, Botfuel, Recast.ai, and Rasa. So the people use Dialogflow also because it's for free. And the things for free are better. So let's do a guess. If I explain to you how to do an NLP and you get out of here doing an NLU, where do you think that your NLU will be? Will be here, 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 or here? Between better than Watson, between Botfuel and Recast? One guess? Yeah, but okay, it's these people has millions of dollars invested, so it's impossible that we get here. No?
Sure. The best.
Yeah, it's the best. So remember that we talked about Lsdm, we talked about word2vec, and now we are talking about artificial intelligence using neural networks. So imagine these three utterance, okay? These three intents and the utterance, and you see that the utterance that we trained before with Lsdm classified to the intent, and then phrases that are not in the training data, and we want that tell me when you born it is classified as birthday, who is developing you is classified as a developer, tell me about you is classified as who. So the Lsdm tackled the problem character by character. What if we have something called regular expression, is something very new, okay? It's incredible. Regular expressions is something very new that is able, call me crazy, yeah? To recognize the white space and convert that to an array of words. Okay? Instead of going through to the characters, we are going to the words, because it's a very small problem. Okay? This is called tokenizer, and it's very old. Okay, it's the first tokenizer is previous to cover. So you want that who are you is tokenized as who are you. Say about you is say about you. And here is the first problem. What happens when you have a contraction? You expect that this tokenized as you are separated. Okay. Usually, to be honest, the tokenizers that you find online are not able to do that. And it's very simple, so I don't understand. So we tokenize it, and we want to train the neural network. So what we do is we have the words, and we can know the different words that appear in the text. Okay? And I think that are 11 words or something like that. And we can have every single phrase converted to an array of ones and zeros, where if we have an array that is who are you, say about why, here, blah, 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 each position of the array represents one word, and then you convert your utterances to a vector of 1 and zeros. Simple as hell. Okay, and you want these vectors of 1 and zeros to be classified. You train the data. Okay, the first 3 vectors are the who, the other 3 vectors are the da, and so on. So let's see what's happened. Okay, I have here. Excuse me, I am not showing the code. Okay, I have here several examples. Okay, excuse me. This thing is using the NLP util and the NLP manager, and I will explain every single step that I follow to improve my NLP, so you can understand the process and not only what it does. Because if you understand the process, you will be able to improve it, and you will be able to reproduce it and to explain it. That I think that is better than give you a product and say, okay, this works. Okay, if we have this like that, I can go to the NLU benchmark and do, excuse me, I lost my code again. I am trying with the wrong corpus. Okay. To understand the corpus, let's see a chatbot corpus, for example. We have this information. I have the text. I want to go to Marienplatz, that is a Platz in Munich, and the intent is find connection. And also it giving me information about the entities. What is entity? Imagine that the intent is the name of a function. Then the entities are the parameters to that function. Okay? So if I want to go to Marienplatz, given the fact that the intent is find connection and the text is Marienplatz, perhaps inside I have a find connection function that reflects Marienplatz. It's so easy as that. Okay? To understand the concept of function and entity. And you have plenty of that, and for each one you have training false or true. Okay? The ask Ubuntu is really all Ubuntu, blah blah blah, make update. Okay? As for Ubuntu. And the web applications corpus that is here is, for example, user can reset their passwords anymore, blah blah blah, and the intent is change password. Okay, this is how they tried the other NLUs. So we will train our neural network that is a logistic regression classifier. Is what I explained before. As simple as that. Is the 101 of artificial intelligence is when you go to a class of artificial intelligence is what is explained the second day, and with a tokenizer, only tokenizing the words, we got a score of 0.86. Okay, 0.86 is lower than Dialogflow, but we are near. Okay. NLU evaluation, and we are only tokenizing, and we see that we are in 0.86 and Dialogflow is in 0.87. So with the most simply algorithm of artificial intelligence on the world and only tokenizing by words, you get almost Google. So I don't know where they are investing the money, but no. And remember that we have contractions, okay? The you are, they are, and so on. This is without taking into account the contractions. Okay? If we go to the code and I open the tokenizer, if I found my mouse, okay, we have here in NLP steamers tokenizers, and we have the aggressive tokenizer English, and we see if replace is true, then do whatever. If replace is not true, that is the case, the only thing that it does is split by words. Okay, is the most simple. And if replace is true, is using this to replace and apostrophe T by not, S by is, R, have, and cannot, gonna, and wanna. Okay, that are the three contractions. So let's change the aggressive tokenizer to use these contractions. I lost my code again here. If I go to the index, here it's only to put a true here. Okay? I'll go again and I repeat. I broke something? No. 0.8686. So we can go to the current slide and it's growing, the red area. Okay? Simply as hell. Only tokenized words. But there is a concept that is called steamer. Remember our words? We have one problem here. That is, developed and developer is not developing, are different words, and born is not born. It's not the same word. So there are two ways to tackle the problem of identifying the meaning of a word and extract the meaning. One is lemmatization. Lemmatization is to extract the lemma. The lemma is the word that represents a family of words. Example, R is a representation of be, to be, okay? But for that, you need a very big dictionary with all the possible conjugations and all the possible variables from a word. And you don't want that. Imagine that we use prefixes and suffixes to give meaning, like augmentatives, diminutives. And you have to have a very big dictionary with all the possible words from a language to represent the lemma. So it's a very hard problem. But there is something that is called stem. Stem is not the lemma. Stem is the root of a word. Example, if we are talking about developer, developed, and developing, the stem is develop. Okay? If I go to anti-developer or big developer or developest, the stem is develop. Okay? En Spanish, la raíz de una palabra. Ok, lo dimos en lengua y en coñazo. Estás grabando. Okay, so it's something that we study in the school here in Spain. The teacher explained because this word came from the Latin word from Roma, that the Romans. Boring, but there are algorithms that for a given language are able to calculate the schemes for this language. Okay? So I went to a library called Natural, and I used Natural to use the steamers that they already have implemented in several languages. Okay? So if we steam, this is the result. You remember who developed you and who is your developer? Now it's replaced by who developed you, who is your developer. Okay? So what happens if instead of using the tokens, the result of the tokenizer, I train directly with the strings instead of the tokens. So I can go to my code, remember my code, use a steamer, true. Okay. And I go and I run. Okay, 0.8978. 8978 to understand. Only with this improvement, we are getting better than Rasa. Remember that Rasa used word2vec and used mighty and spicy that are very hype and very modern, and that are able to learn corpus, very big corpus, and so on. But perhaps it's not the best choose for chatbots, because with a simple thing that you can do in your house, with a custom implementation of the artificial intelligence, I'm not even yet using a library. It's an implementation of a mathematical implementation done by myself of the logistic regression classifier. I took the book from Peter Norville and I implemented from that. Okay? With something handmade, we are getting better than commercial tools. And with something that makes sense, and something that you can find the resources online and are open source and are MIT and so on. So, okay, if we are here, let's improve. The first thing that I think about is, okay, Natural is a good library that includes steamers, but it's not the steamers that are used in big companies. So, what are the steamers used by big companies? The steamers used by big companies that are in Solar, that are in Lucent, that are in Elasticsearch, are called Snowball. And Snowball is an implementation of the steamers based on the steamers of a guy called Porter that created the Porter algorithms to optimize several languages and are done in Java. So, okay, I have the Java code, I need the JavaScript, let's write something to convert from this format to JavaScript. The result is a crap, is not readable and perhaps not maintainable, but the rules of a language don't used to change. Perhaps in 1 millennium, the way to calculate the sting of a word in Spanish varies, but not in 100 years. And I think that in 100 years we will have better artificial intelligence than that. So I must tackle a problem for the next 5 years. And in the next 5 years, the steamers will not change. Okay? So I changed the steamer from Natural from steamers converted from Java Snowball to JavaScript. Okay? And again to the use alternative true. I go to the console, delete this. We are over 0.9 now. Okay, it's not still so much, but we are getting to both 4. Okay. So next step. Okay, my neural network is homemade. Let's go to a good one maintained by people smarter than me. I tried with TensorFlow.js, but TensorFlow.js didn't give me the good results in time, and it was not the best. So I continue with Brain.js. And I trained it with Brain.js. I have here the training through. And surprise, surprise. Now you are seeing times from two algorithms, binary relevance, that is a spoiler, but okay. And okay, 0.89, it goes lower. It goes lower, but because I am using the default brain.js. But in the brain.js, remember the activation function. The activation function can be usually sigmoid, hyperbolic tangent, ReLU, and leaky ReLU. ReLU is very bad for this problem because it's too linear. Leaky ReLU is like ReLU. How to explain it? Leaky ReLU is simply, if it's less than 0, then it's 0. If it's higher than 0, then it's x. The leaky ReLU says if it's higher than 0, it's x. If it's lower than 0, it's not 0, it's a little line under the 0. So I tested the same thing with this corpora and with other corpus, and I got to the conclusion that sigmoid and ReLU are very bad for this problem, but hyperbolic tangent and leaky ReLU are very good. Then I have to take one decision. I choose a hyperbolic tangent because it gets faster to the solution, but not the best solution. Or I can go to the best solution, see how many times. So I tried with a big corpus, and the training was in 2 minutes. In my machine, 2 minutes is something that you can't understand for training a bot, because it's the training you don't do it on real time. Usually you decide the utterance, you decide the user experience of the chatbot, and you train with something that you think it. It's not something that you are clicking the train button every day at any moment. So 2 minutes is good enough. So I changed the parameters of Brain.js to train using leaky ReLU. And it's called fine tuning to see the difference, because of course it's better if you see the difference. In the brain classifier, if you have fine tuning, it says, okay, the activation is leaky ReLU, no hidden layers, that is the default, the learning rate is 0.1, and the error threshold is this, okay? And I have also a total timeout that I say, okay, the maximum time that you can spend training is 2 minutes. And this is something that you can set from the settings that you pass to the class, okay? And with that, if I train, so is what's simply as that. Is what's simply to tokenize, to Lsdm, and to see in the NLU what is the best way to train this problem, because every network topology and every activation function fits best to certain problems. So usually this is called hyperparameters, and there is an exercise for every data science or every engineer that is training artificial intelligence, that is the tuning of the hyperparameters. If you tune the hyperparameters, you get here, and you surpass every single tool in the market. And it's simple as that. The source code is open, so you can play with that. But I didn't want to stay here. I wanted to go one step further. Okay, let's use me as my new competitor. I want to improve myself. Well, I have this slide that is, I don't understand why companies investing millions of dollars in this thing are not fine-tuning their own artificial intelligence networks. Something that I cannot understand. They have PhD people working there, please. So, what we saw is a multi-level classification problem based on lines, but there is one way of tackle the problem of multi-level classification that is called binary relevance neural network. What is the binary relevance neural network? Well, this is the arrays of ones and zeros. Okay, you see over the features. The features are the stems, and you can see in red the positive for who, the positive for you, and the positive for developers. Okay, so this is something that I already explained, but you now can visualize how it looks like internally. And binary relevance tells you, instead of go to the full problem with one neural network, create one neural network per intent. Okay? So instead of having a big neural network, now we will have 3 neural networks. One for who, one for developer, and one for birthday. And each one only knows this is the intent who, yes or no, and the probability of yes, probability of no. So you have the probabilities for everyone. And this is how internally it looks like. It calculates the bias for the first neural network. This is who, this is developer, and this is birthday. And you have the weights for each of the stems, okay? Are the numbers calculated, but this linear regression classifier is only a line in a multidimensional space, and those are the weights of the inputs to calculate this line. Okay, so we have those 3 representing every single problem. And I still use brain.js, but instead of having a neural network, I have one per intent. Okay? So with this approach, binary relevance neural network, I can have tell me about you, who is developing you, and tell me when you're born to classify. So if I go again to my code, and will you benchmark index false, use neural, true, and I train. Okay, 0.93. Remember 0.92 and now 0.93. So I am getting distance from Watson. But I didn't stay there and I wanted to go further. And remember, every single NLU was trained not only with the utterance and the intent, but also with the entities. Okay? You know, for the training data, you know the entities. And according to the paper, he goes to Luis, implements the entities, implements the intents, and Luis, Botfuel, Ricardo, Dai, Rasa, Diacro, and Watson have the information of the utterance, the intents, and the entities. So imagine that you have, I want to travel to Barcelona, and Barcelona is the entity city, okay? And the intent is travel. You know that for travel you have an entity called city, and you know that this entity is in this position, between that and that character, and so on. So what I did is something that is called data augmentation. What is data augmentation? If you use convolutional neural networks, that are the common use for interpreting sounds and images, you will notice that from one image is not enough to train a neural network. So what you do is to do perturbations or changes in the image. You rotate, you displace, you crop, you slice. You can do several operations to, from one image, get other images. So I applied this principle of data augmentation given the entity. So if I have, I want to travel to Barcelona, and I know that Barcelona is city, I train with, I want to travel with Barcelona, but also I replace Barcelona by percent city percent, representing the entity city. So I train with 2. I want to travel to Barcelona, I want to travel to blah blah city. Okay? And after that, I will not show the console because it has no sense anymore. After that, this is the maximum that I get until now, and is 0.9380. As we round to 2 decimals in the paper, 0.94. And currently this is my record. But I wanted to understand why the other entities, the other intents, I didn't got it well. And I will show you some phrases, okay, how they make the corpora. They have the intent names, and they use a mechanical Turk. A mechanical Turk is something that you contract where you have people from other countries that are getting less than a cent for each thing that they do. You can, for example, contract an Amazon mechanical Turk to classify images in dogs and cats. And what you do is, okay, there you have an image of dogs and cats, and Amazon receives the image and sends it to people, every single image, and they are saying cat, dog, 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 cat, cat, dog, cat, dog, and getting less than a cent for each shot. And they send it to 5 different persons, and they say, okay, if 3 or more say the same, this is the intent. I contacted the guy who did the paper, saying, oh, come on, they use common sense instead of that. But let's use common sense. Is there a document scanning and archiving software? How do you will classify? Known of software recommendation. Who will say that is known? Up your hands. Who say that is software recommendation? Okay, it's common sense. It's software recommendation. It's classified as known. It's impossible that my neural network classify this as known, as the other utterance similar to that are classified as software recommendation. Why? Because there are 3 guys that say this is known because I know.